Hello everyone, myself Yogesh Jadhav from second year Electronics and Telecommunication Engineering, MIT Academy of Engineering. Along with my group members, uh, Suhas Bangale, Amit Ghadge, Yash Chavan, Krishna Kokate, and Heran Barambe, going to present our work on roof structure made from bamboo in the guidance of our course teacher, Rapid Proto, with Mr. Sitaram Suryavanshi sir. We are group one, and now without consuming more time, let's see what is the presentation. So from the beginning, we'll see the basics of bamboo. Then we'll see all the aspects related to the bamboo. After aspect, we'll see the taste on bamboo and product detailing and cost estimation. After cost estimation, we'll see problem faced and solution on it during all the structure presenting. After this problem test and solution, we'll see the references and we'll then conclude. So let's begin. Firstly, the basic of bamboo. Bamboo is a flowering permanent evergreen plant which belongs to a grass family. Basically, it is versatile, strong, and renewable as well as environment eco-friendly material that can be easily grown in where the water is more in. And bamboo is also considered as a fast-growing plant in the world. It is the most fast-growing plant. Bamboo is now bamboo has taken a very special place in our life. It can be used in most of the structures, which and everyday tools. We can use bamboo for making homes and tables. So all in basic and regular tools, we can use bamboo easily. And uh, actually, the bamboo is cost effective, and that is why we can use in more content. Let's see all the aspects of related bamboo. Bamboo aspects are they can be bamboo is so cost effective, so we can use uh, in any way where cost is matters. And like in Assam and all these countries where bamboo is in more content, they use bamboo for most of the houses and all the things which are in everyday use. So at last, I say that bamboo is very cost effective and it can be used for like in any elastic or the house like structures. So after we'll continue. Yes, your method.
Thank you, Yogesh. Now we will see the prefabrication bamboo taste. So there are different tastes of bamboo. So before making the final product, we have to do some basic. Thank you, Yogesh. Now we will see the prefabrication bamboo taste. So there are different tastes of bamboo. So before making the final product, we have to do some basic tests. So as we want whole dimension as assembly vertically, we calculate it by considering the diameter of two supporting bamboo and also by considering the fish mouth cut. So the slant truss we cut by using uh, hypotenuse rule and other parts by using basic geometry. Uh, and then we divided the figure of truss into equal uh, portions, and then we have calculated the uh, force in individual member by using method of joint and method of separation. So now we are going to discuss some test. So first is tensile test on bamboo. So the basic idea behind the tensile test is to place the sample of bamboo between two fixtures. We called them grips, which clamps the bamboo basically. And the bamboo has known, know the bamboo's dimensions like length and cross-sectional area. And we then begin to apply the weight to the bamboo gripped at one end while the other end is fixed. And we keep increasing the weight, often called the load or force, in physics, and while at the same time measuring the change in the length of sample, length while adding the weight until the part begins to stretch and finally breaks. Stretch in the sense the result of this test is a graph of load, or we can say amount of weight versus the displacement, that is amount of stretch, bamboo stretch. And since the amount of weight needed to stretch the material depends on the size of the material and of course the properties of the material also. Now in the tensile test of bamboo, it was found that we done the tensile test on bamboo, so we basically got the output that typical bamboo flooring parallel to grain is 105 megapascals, and as reported in reference tensile strength parallel to grains is 200 megapascals for typical bamboo, and for the tensile strength values reported in the values reported is the range of 130 to 138 megapascals. And then there is a compressive test. So compressive test is basically we compress the bamboo, like we apply the opposing forces to push inward upon the specimen from opposite sides, or otherwise we can say compressed, squashed, or crushed force. The test sample is generally placed in between two plates that distribute the applied load across the entire surface area of two opposite faces of the test sample, and then the plates are pushed together by universal test machine. You can see the picture of machine in the picture. So the fascinating properties and the uses attracted the engineering researchers quite late, and various researchers started working on bamboo for its use as a structural material. And the laboratory tests are carried as per ISO specifications. ISO recommends that specimen shall be taken from the bottom part, that is the middle part and top part of each curve, and this specimen shall be marked with the letters B, M, and T respectively. So you can see them in the picture. And for the test is the tensile test. So the average tensile strength of bamboo is situated roughly around like 160 Newton per mm square, which is often 3 times higher than the most conventional construction grade timbers. You may know the timbers, right? And here is the tensile test of bamboo. So here you can see in the picture that one bamboo, upward bamboo is cutted with fish mouth, and fixed on the horizontal bamboo with key, and then put on the two bamboos, and then the force is applied on it. This is the tensile test, and now the joint test. The result of this analysis provided an overall basis of determining the effectiveness of joint. The result of this test seek to provide reference loads for when mortar should be inserted into the anchor joints, which would help to reduce cost and cost associated with mortar use, and give us the structures additional lightness. So through the structural analysis and references available, loads were calculated from the specific bamboo canopy structure. Now, so the further part will cover by Amit. So Amit, you can continue.
Thank you, Suhas. Next part is product detailing. Our group had to make a rooftop. It consists of two main components, namely the roof frame and rooftop cover. The the roof frame is made with three bamboos, of which 2 feet bamboos are connected adjacent to each other, and the bottom base is 7 feet, so 7 feet long. It is further supported by two bamboos, 2 feet and 4.7 feet, connected horizontally. All the bamboos are joined together with the help of skids, and the horizontal bamboos are fixed with the help of through joint and keys, due to which they are tightly fixed. The rooftop consists of 50 cross-sectional bamboos placed vertically in a conical slab manner to form up the cone-like roof. The whole frame and rooftop are screwed with the nut bolts to the vertical bamboos to keep the structure tightly mounted to each other. Make the anchor and strip the bamboo with suitable dimensions. The next part explained by Hiram.
Okay, thank you, Amit. So next part is a cost estimation of the product we have made. That is our roof frame. So for the roof frame, we need total length of bamboo is used is 9.8. So which is approximately equals to 10 meter. So per meter cost of the bamboo is in market is rupees 30 per meter, and the rate of electricity is used is 6 rupees per unit, and the rate of skilled laborers are rupees 250 per labor, and the rate of hire machine is rupees 30 per hour. So total cost estimation is bamboo. First is bamboo, that is 10 meter, and 30 meter 30 and the cost of bamboo is 30 rupees per meter. So cost of bamboo will be 300, and the second one is electricity. Roughly electricity use was 50 units. So final cost will be of electricity will be 300, and labor cost was 250 per person. So the final cost will be 1,500 of labor, and the machine was used for 4 hours. So total cost for the machine is 120 rupees. So total cost estimation of the product is 2,220 rupees. Now further problems faced and the solution will be explained by yes sir.
Thank you, Aaron. So the problems that we have faced are the first problem is to giant full 9 feet bamboo. We have to cut the anchor. Along with this, so to fix it, we have to add the keys to connect the bamboo is not sufficient. So we have to make it. Basically, we have to make it strong in all the aspects. So we have used nut bolts uh, to connect horizontal bamboos. These nut bolts makes the structure strong. And the another problem is while working on the bamboo, sometimes we have to uh, pass the key through the nodes of the bamboo, and it is quite difficult to drill the hole at the nodes. So we have drilled it and work some extra to drill the hole through the node. And another problem is it is important to the bamboo is straight, so we have to find the proper bamboo, and if the bamboo is not straight, then the structure will become weak. So we have to identify the proper bamboo, and uh, it will make our structure stronger. The next part will be explained by Krishna.
Uh, Thank you, yes. Here we are all discussing about rooftop solar. After that, I'll give some basic description about bamboo and how we have to be test, and also which problems, which solution and problems are discussed. Uh, Here, our model, our product model is economical, feasible, and eco-friendly to do all above properties. So anyone can afford bamboo and mix objects with easily, and there might chances of damage rooftop due to some environment effects. So applications of paint and varnishes is necessary periodically. Uh, Due to laser mobility and affordability, it design need to be changed with proper precautions of chance. Nice. Nice. There are some preferences. And thank you.